challenges. There will be four hurdles challenges in Reeborg's world. Uh, so we will be solving it one by one. So let me share my screen. So yeah. So let's go to first hurdle challenge. So before it is loading, let's see what are the instructions there. And so they are saying Reeborg has entered a hurdle race and make him to run the course following the path shown. So they are saying we should know the functions move and turn left, what we have seen already yesterday for to move the robot. And in the course of that, they are saying you have repeated many times some pattern so that you can like define a function name called jump and use it to simplify program. So hint to use the loops instead of calling function multiple times. So the final position of robot must be 13 and 1. So if I go back to the loading, I'm just taking time to load. So the same what I have defined is it will give me here. You can see it in world info also. So they are saying we have to go to this 13 and 1. So this is all what we have written yesterday. So I am just starting only from day 1 again. So if we use the move, so here what are the commands we have? Move, turn left, take, put, and it all have different functionalities we will be using going forward. And we have some conditions as well, condition functions. So depending on the instructions provided, we will be using that. So if I move, the robot will move one block, and then again I have to turn the robot to left and then move. So for example, I want to cross this barrier, but if I give the move twice, so it will say I have hit the a wall, whatever we have given. So just I'm running. So we got error, so I hit a wall. So without hitting the wall, what we have to do? We have to cross the barrier. So, but robot will move only in the direction where the facing will be. So move. So now if I want to move to up, so I have to turn the robot to its left hand side. So it's like, so I will be again resetting it. So and then turn left. So what it is saying, the robot didn't follow the correct path. So the final destination should be this flag. It should come to this flag. So again I am resetting it. So now I know the how the robot is moving. So it's like one step move, and then next step is turn left, and then next step I have to turn it uh, again move. So after turning it move, and I have to turn it again to its right hand side, right? But to turn it right hand side, we have to write 3 times because there is no defined function. So we have to turn the robot multiple times to get it to right side and left. And then if I give the move, so the robot is expecting, I am expecting the robot to move to x2 and y, like x3 and y2 coordinates. So if I click on it, okay, So stopping at the execution, resetting it, and again playing. So it got what I'm expecting. It has got to that location. So and then again, what I have to do? I have to turn the robot again to right side. So the face will be visible like so. But to turn the right side, we have to turn the robot 3 times. So for this, we have already, instead of writing this line 3 times, we have already defined a function. So let's define it inside here only. I just for demo purpose, I have just kept this function library module to demo how the modules works. But here, what we are defining another function where it does turn left multiple times. Instead of you have writing this turn left 3 times, I just will write and write and then again. So my robot has stuck at this location, so I have to turn it right and I have to again move it. So it's like we are rewriting it again and again. So we have decreased the lines of code now, and then we are moving the robot. So now if I do the play button, okay, reset and play. Yeah. So my robot has come to this. So it is facing this side, but I have to turn it left again to go to follow the path. How we will be doing? So I have to turn the robot again to left. Then we have to move it. So if you carefully observe, so the robot is standing here. So we have uh, the similar type of functions where the robot is going in the directions what we are defining in this commands or the functions we are defining. So we are telling the robot, okay, you have to turn left and to turn left and move. So similarly, so if I now again I just removing this and then I am resetting it and again I am playing. Okay, it's like typing. So my robot is so you can see the execution loop also like so my robot got turn left. So every time we are calling the turn right function, so the execution is going to this function and executing all the commands whatever we defined here. So to continue the same thing, so if we see, so multiple steps involved, right? So it's like I will just copy this 6 times. So I have 1, 2, 3, 4, 5, 6 hurdles. 5, 6. So it's like 53 lines of code, but it is like everything is repeating, right? So just again, So my robot is going in whatever direction I have set, it is going fine. Yeah. So I got the correct answer. Like, so my robot has worked fine. But here what we did, we actually rewrite the code multiple times. The same code we have written multiple times. So instead of that, what we can do, we can actually define this everything, the six elements to here, right? So as they mentioned, we have to, if the this is a repeated pattern, we have observed some repeated pattern. So we have defining the jump function, define jump, and then I am giving to everything. Just, so this is indentations. So whenever you're defining any function, the all the commands inside the function should have indentations. So better to use tab every time for everything in Python. So now what I can do, I can call this function six times instead of write all this uh, 7 lines of code multiple times. One, two, three, four, five, six, seven, eight lines of code multiple times. I will be calling the jump function six times. I think that's enough because I have only six hurdles. One, two, three, five, six. Now again I am resetting it. Let's see if it works or not. So you can see the execution how it is going. So the Python interpret so the execution as same as it is. So you can do step-by-step execution also if you are working in that. Like once the class is done, you can try to solve it on your own. Yeah. Now it is done. So again, instead of calling functions multiple times, here the comes the loop concepts. So what I will be doing, so instead of calling the jump function multiple times, I know I have to call it for six times. And I know I have a function called like for I in I am using range function what we have discussed. So it's like I am giving 0 to 6. So what it will do, it will goes from 0 to 5 in increment. So it's like 6, I meant to say 6, 6 times it will execute the loop. So or you can give 1 to 7 as well. Like, so what we have already defined. So it's like the starting range and then the ending. This should be plus 1 every time the in the range function it will execute up to n minus 1 only, stopping point minus 1 only. So from the starting point, and then and the step we are not giving anything, so it will be one by one execution only. So I am calling jump. So here so it's like I am saying 7, so it will be executed 1 2 3 4 5 6. So 6 times the jump will be executed. So let me try that again. So it is, if you see, it is going loop multiple times. So and then executing depending on the functions we are calling, it is calling all the commands it is turn right, it is going to turn right function. Yeah. So similarly, instead of uh, so if you want to write a while loop also, it's something similar like number of. So just I'm defining number of jumps jumps equal to 6. So while so what I'm defining while number of jumps greater than 0. So until this condition satisfied, the while loop will run. So once this condition not satisfied, once only one this condition is not satisfied, then only it will terminate the loop. So what I am doing, jump, and then we are actually what we are doing, we will be decreasing it. So it's like we have increment operator we already used. Now we will be using a decrement operator. So it's like we will be decreasing one and then assigning it back. So it's like until it goes to 0. So here we are not giving greater than or equal to, so it will execute only 6 times. If we given equal to 0 also, it will execute 7 times. So the first execution step at 6 it will start. 6 is like so if it is greater than 0, so you can actually print the statement also. You can after decrement also you can print, after increment also you can print. Sorry, just this for loop. So I am resetting it. So here just for our understanding. So the number of increment is decreasing. If you see, so the print statement it is 5 4 3 2 1, and the at last it will come to 0. It is done. So it came out of loop. So if we haven't given this statement right, so it will go into infinite loop. What we observed already in the starting classes. So, yeah. So we have to very careful while using the while loop. So we have to check the conditions properly, and then only we have to use the while loop. Otherwise, it may result in infinite loop. So if I forgot to give this condition of decrement, then it will goes on increase. So again, let's see that case also. So it will goes on and it will, the robot will hit or something. It will stop the execution. Otherwise, it will goes on. So the number it will be always 6. There won't be any decrement. Yeah. So it got hit the wall. So it's like it because it got hit the wall, the execution got stopped. Otherwise, it goes on uh, the robot will goes on until there is no wall. It will goes on infinite loop. Yeah. So any questions before going to next challenge? So here everything is fixed, right? So the hurdles are fixed, and where the flag is, there it is also fixed. So let's go to the next challenge. So it's a simple, the first thing is everything is fixed. Now the second challenge will be interesting somewhat. So it's like, let me change here itself. You can actually do here also. So it is again, let's go to, so but does not know in advance how the long race it will be. So make him run the course and following a similar path to the one by stopping at the flag that will be shown after the race started. So it's like they are giving the flag may be at this point, at this point, at this point, at this point. Generally it is at 13, 1, but it can be at anywhere. So what we need to know is at goal. So this is the new function defined by the website itself, and we have to use the negation apart. So negation, we have to know how to use the negation also, and we have to know how to use the while loop. So now we don't know how many times we have to jump the function. So it's like the poles will be 6, but we don't know at how many times the flag will be. So if I click this, so it is going. So the my flag got at this condition, but it's the robot is going. So actually our code fails. So we have to use the at goal function. So similarly, so now we don't know how many times we have to jump, but we know we have to jump, but how many times we don't know. So for that, what we will do, while not of, so they have given the at goal function, right? So we will be using this at goal function. So it is like we are saying the robot, so you are at goal. So here we are negating it. So so we are using the same jump function also. So we are negating it. That means until unless it is not at the goal, it will continue jump. So if it is at goal, it will come out of the loop. So it is similar to while not at goal is similar to while at goal not equal to true. So while not at goal is similar to, so you can use anything, but what negation is like, what they have said negation is like, so while not at goal, we have to use the function. So it is similar to at goal not equal to true. So this function will return a boolean value when the robot is at flag. So then only it comes out of loop. So otherwise if it is not at flag, the while loop will goes on uh, like iterating. So let's do again reset and then let's try again. So if you see the now it is at this point. Yeah. So now our code is working fine. So similarly, let's try with not. So it is very readable code. Why we are using while not at goal. So it is. So that's what it is. I meant to say. Very easy to read. Let me reload again. So now it went back to 13. The flag. done. So even again, if I try to do it now, again the flag comes back here. So it's again depends on one of the uh, like we click on the play button, the flag position will change. So this is the second hurdle we have done. So any questions in the second hurdle? So it's very straightforward only. So we just given a while condition. So if it is not at goal, then you have to run the loop. Otherwise, if it is a goal, so we are negating because while loop will run until that function will not be negation. So if every time the function is uh, returning true value to the while loop, it will execute goes on execution. So so now we will go to the third challenge. So here we are now we don't know like I meant to say where the how many walls are there, how many like at where the walls are there and how to go. So here what they said we have defined wall in front of function where robot will take care of that like if it is there, so robot will get to true or false, and then depending on that condition we have to write the code. So the front is clear also we can use for another purpose. If robot is going upwards or downwards, so it is not having any uh, obstacles, then we will use that function. So it's like in the next chapter actually we will be using that. So it's like all the wall sides are same here, but if some the pole heights are different, then how we will be doing that? So here, so they have given again how to use a while loop and a if statement. So we have they have given us a hint. We have to use a while loop and an if statement. So if I run the same code, it will fail directly. It will fail. So it's like the first itself it is trying to move. So instead of checking whether wall is there or not, it is trying to move. So now we are using the same at goal function, and now what we will be doing if so here we are giving condition if wall in front. So here you can use syntax like this. So it is similar to this one. So then jump else move. So if there is no in front there is no wall, then we have to move. So for example, now if you see, but here we have to little bit change because when it is in front, we have to turn the robot to left. So here we are actually changing, we are commenting it out. So if there is no, we have already given the condition, if there is no wall in front of me, it will move straight. Otherwise, it will call this jump function instead of moving. So before all the first and second codes is all everything is fixed. So that's why we have given move function to move one bit. But here the walls are not fixed. It they may vary. So we are using this function So whether it is true only, then it will call this function, otherwise the robot will move. So for example, if you see 5, 6, 7, there are no walls, so the robot is not needed of using any, I meant to say, any jump functions here. So it can directly move one, two steps. Then here also 9, 10 also it can, instead of using. But before in like in before exercises, what we see, we are actually defining the robot should uh, call jump every time because everything is fixed. But here they are varying. So now I am resetting it. I am line 23. Okay. The indentations, we should check the indentations are correct or not. So if you see, there are no walls until 6. Now it got a wall. Now it is calling the function. Now again, so here what we are doing, so we are using the while loop and if conditions, what we have learned already, so that the robot, we are making the robot to check whether the condition is satisfying or not, and finally it is at goal or not. So this is our final condition to satisfy, and this is the barrier conditions we have to satisfy. Any questions in this? So this is also straightforward, but just we have to know how using. So let's go to fourth hurdle. So it is little bit difficult. So now it is like the position, the height, and the number of hurdles also changes each time the world is reloaded. So it's like, so now we have to use the programs what we have written already for hurdles 3 and before that, and we have to run a program. So it should, the program what we should writing, it should actually run for all the hurdles also. Like it should work for the 1, 2, 3 also. So that's the main thing. So now, so let's go back to hurdle 4. So here, if we see, so now we don't know the height. So but we know it's like the heights are differing. So here we have to check the conditions. Like, so we are checking with this one, wall is on right or not. So so how we will be measuring it is like, so here the basic functions what we are defined. So for the robot we are saying, uh, if it comes the wall, so here it will go to the execution at, if wall is true, then it will call this jump function, then fine. So and then it will turn left and it will move. But again, if it is moving right, but again once it will, the move is only for one step, right? The robot does not know how to go to 3 steps further. So when it turn right, it again, the our code will fail, our robot will hit the wall. So if I run the same program for this, So okay, it got fall. Now it turning right and then it hit a wall. So but for here what we will be writing is we are actually will use a while loop while wall and right. We will be using this function. So until wall is on right, we are saying the robot to move. So if wall is not there, then you can turn to right and move and turn to right. Let's see whether it is working or not. Actually, it is going in another directions. So it is not. So here the robot is saying so it is not coming still here like so until unless it has some obstacle, so it should move in the downward direction, right? But what it is doing, it actually going only one step move and then again turning right and again turning right, so the path got disturbed. So there is another front is clear. Sure, sorry. So what we will be doing is, so once the robot turn right, we will check while front is clear. So front is clear until unless front is clear, it will go still here. And but if it hit this, so turning, we will be turning to move the robot in the direction what it is. So once the loop got a false condition, so here the once the robot returns here, the while loop will going to say the while loop will end. Okay. So now let's see if my coding is working or not. So it is going wall is it got wall and then it is going, but it is not following the path. So here what we have to use. Okay. Build here. Okay, wall in front. Okay, let me so Okay, let me do the one step by step execution. So okay, my code got while move, turn right. Okay, I think it's not correct here. So it is not the value what I am defining is not correct at the correct position. So I have to say my robot to move and then turn right. Okay. And then I will be using while front is clear. Now it should work. So again, if I run this, just I'm seeing the execution. Okay, it is going, moving until wall is right, then turn right, and then turn right, and then it is moving until it got uh, obstacle, and then again it is checking, and then again it is moving. So again, once it got obstacle, it turned left. So now it is moving. Finally, we have done with huddle. So it's again predefined functions. We need to know where to use and the conditions like while condition also. We have to check where the positions. Like I have defined incorrect position while function so that the robot has not followed the path they have given. So now it's like the front again. You should understand wall is on right. The robot will check if the on its right side whether the wall is there or not. Uh, Front is clear means it is like the robot will check for at front it is having any obstacle or not. So at this position it is saying at fourth like x4 and y1 position. So there is for the robot facing there is a obstacle like the wall. So until then it will move and then if it come out of loop and then it turn left. So again there is no wall in front. So here like again the execution goes here and if there is no wall it will just move. So if we use the same code for hurdle 1, so let's see. So here we are not defining any how many times we need to go, how many times we are just giving the code what we have already written. So this is how like incrementation of logic we have to build. So first to start with small and then using multiple concepts we have defined. So the same program is used for multiple hurdles. So you don't need to again define anything. So it's like for range function we are not using any range function, any function. So let's see if it is working for hurdle 2 also. fundamentally it should work because we have defined all the logics one by one, like from hurdle 1, hurdle 2, hurdle 3. Yeah, it is working for hurdle 2 also. Now if we go for hurdle 3 and reset, yeah, yeah, it is working for all the hurdles. Yeah. So any doubts here? So we have implemented all the logics, like all the concepts, loops, concepts, what we have learned already in this hurdles challenge. So try to practice. And we have multiple. You can actually use multiple functions also, like wall in front, wall right. You can use front is clear, right is clear. So there are multiple challenges. You can just if you see it's the first challenge. So it is very nice a way of learning code. So except maze, you can just try everything. We will check maze in maybe another class. If no questions, I am stopping the recording.